Okay, so my players now have the ability to enter into a lottery contract through the enter method right here. After the contract gets some number of players who have entered the lottery, then the manager of the contract should then be able to call the pick winner function, which I haven't implemented yet. The goal of this pick winner function is to randomly pick a winner out of the list of players. Emphasis on randomly. So I want to look at the list of players that are in the players array and randomly pick one entry in there and say, hey, congratulations, you're the winner. You get some amount of money. This function is going to be challenging to write because if I were using any other language aside from Solidity to pick a winner, I might just say randomly pick a number and then use that number, pick a random element or random index out of the players' array. However, with Solidity, we do not get access to a random number generator. There is no such thing as a random number generator with Solidity. So instead, I'm going to kind of fake the random aspect of this. One thing I want to be clear on, there is no random generator. So the code I'm going to write to randomly pick a winner is a pseudo-random number generator. By pseudo-random, it means that it's not quite random in that our system for picking a winner can actually be theoretically gamed. In other words, people can actually cheat on my lottery. So why am I making this contract at all? Well, it's one of the big topics around Solidity. It's tough to do random number generators, and it turns out a lot of contracts that people want to design sometimes require some aspect of randomness to them. So why am I going to do it if it's supposedly so hard? Well, let me pull up a diagram. Pull up the diagram, and here I go. So this is what I'm going to be doing. I'm going to be taking the current block difficulty. The current block difficulty is something that takes some amount of time to process on an actual transaction. That amount of time that it takes to, the amount of time that it takes to solve a block, that's a block difficulty. So it represents, it's going to be represented by a block integer. And then I'm also going to take the current time, and I'm going to take the list of addresses of players. So I'm going to take these three inputs and feed them into the SHA-3 algorithm. SHA-3 algorithms, or SHA-3 algorithm hashing, takes some amount of data and then spits out a really big number in hexadecimal. I'm going to take that really big hexadecimal number and then use that to pick my random winner. The current block difficulty, the current time, and addresses of players to some degree is already known ahead of time. So whenever someone wants to pick a winner, we kind of know what the current time is. So like if I send a transaction in to pick a winner in my contract, in theory, I could have a reasonable idea as to what the current time will be when this function is executed. I also know ahead of time the addresses of the players. And I probably also know the current block difficulty. So if I know these three sources of randomness, then it's not truly random. There really is no good idea of random number generation with Solidity contracts. If possible, you want to try to design your contracts to not include the idea of randomness at all. There are some workarounds to this. I'm going to link these workarounds at the bottom of the video, however. Now, I do want to let you know these workarounds are more difficult. So in this video, I'm going to take this approach, but if you have a project where you really truly need to get some random number, then you can check out the article that I'm going to link below in the description section of this video. Okay, so let's start writing this function or this random number logic. So I think it would be handy to make a helper function that I can call it any time that will generate a random number. So I'm inside my remix and I'm going to make a helper function. I'm going to call this helper function random because its goal is to generate a random number. So here goes, function random. Okay. Let's see. I'm going to make this random helper function private. And I made it a private function because I don't really want anyone else to call this function. It's just for me, for the purposes of the lottery contract. Next, I'm going to mark this as a view type. So view. It's a view type because I'm not going to modify any state. So the only goal of this function is to return a random number. I'm also going to say that this function returns some value, which in this case is an unsigned integer. Or you may have seen it as uint, like so, okay? Now remember that an unsigned int or unsigned integer without any number after it is an alias for uint 256. So technically this is a uint 256. So inside of this random function, I'm gonna take those 3 pieces of pseudo randomness. So I want my current block difficulty, I want my current time, and I want the addresses of my players, and I'm going to feed them into the SHA-3 algorithm. So first I have to reference the SHA-3 algorithm, and you do that like so. There it is. Okay. And then inside the SHA-3, I can pass in the pieces of elements that I want. By the way, the SHA-3 algorithm here is a global variable or global function, so I don't need to do any import statements or require anything in. You'll also sometimes see that, like you might see the SHA-3 algorithm like this. You see that right there? I don't know what that is, KECAK or KECCAK 256, KECAK. Anyway, but KECAK 256 and SHA 256 or SHA 3 are both the same. So this KECAK 256 algorithm is a class of this algorithm, and the SHA 3 is an instance of the algorithm. So they're both the same thing. All right, so now I can pass in the sources of pseudo randomness. And so first block, not black, block. And I'm doing block dot difficulty. Okay, so the block variable here is also a global variable that we have access to at any given time. Difficulty will be a number to indicate how challenging it will be to seal or solve the current block. All right, and then, so I do comma, now. All right, so now is also a global variable, and then I can, after the now, I can actually reference the players, okay? And, all right, so now inside the random function, I do have to ensure that I return an unsigned int, but this is a hashing algorithm. It returns a hash. So a hexadecimal number, but we're saying that we want to return an integer, right? So we can convert this hash into an integer by passing in the hash that I'm going to be generating into uint function, like so. So what I do here is basically do uint, oh, come on, uint, and then I wrap all this inside of it. What do we got here? Parse error, expected token, embrace, cut, view. Oh, I need to separate this. There we go. Okay, let's see. Okay, so this is going to take the hash that I generate, and it will turn it into an unsigned integer. Okay, so actually, before I do that, because I kind of jumped the gun a bit here, let's just go ahead and let's see. What steps do I want to take? So let me see if I could, okay, I'm getting, all right, let's just move. Oh, I forgot the return or returns. There we go. That's what that arrow is all about. I forgot the returns. Okay, so now what I'm going to do is I'm going to go ahead and erase these other contracts that I had deployed earlier. And I'm going to go ahead and just deploy this right now as is. Before I was kind of jumping the gun here. So I'm going to go ahead and deploy it. Okay, so I deployed this lottery contract. And let's see, what I want to do here. I click on enter, no. Right. This needs to be public. There we go. And now we go ahead, I erase that. Let me redeploy this. Now if I open it, random, there we go. Now if I click on that, so I get, I'm getting a, interesting, random. I'm trying to click again. I'm only getting, the interesting thing here is I'm only getting a 0. It's not allowing me to run this again. What am I missing here? So we were supposed to return a hash, but I did want to return an unsigned int. Let's see, what step am I missing here? So I want to take this hash that I generated and turn it into an unsigned integer. Let me go ahead and actually, was the error here? Return. Private. Not still getting that error. So return uint. Let me see if this will correct it. Return uint, because this is ultimately what I want anyway. I'm still getting that private uint and returns. And now that's when it corrects itself. So I go ahead and deploy this. Okay, I get another one, and I'm not getting random. Is it? Oh, because I kept it a private again. All right. So I do have it. Make sure your environment is a JavaScript VM. So we don't have what I was, because I have this random function that's set to private, and I've deployed this new instance. There's no new button on here called random. There was a minute ago when I changed it to public. So whenever we make a function as private, we get no new ability to call the function directly. So I'm going to change it back to public. Okay. And let's see. So I'm going to run this and test it out to see if I get some reasonable random numbers. Now keeps, but if I put that, no, it needs to have that returns there. Okay. So let me just erase all these, redeploy a new contract. Okay, and then we have random. There we go. That's the effect that I was looking for. Okay. So now you see the random button appear, and I clicked on it, and you see this huge number, this pseudo randomly generated huge numbers. And every time I click it, it's random, but it's pseudo random because we can have a reasonable idea of the block difficulty, the current time, and the addresses of the players. So it looks random, right? So if I click it again, it looks random. So, you know, but ahead of time, you know, people can figure out these variables, and if that's all it takes, then to gain access to money inside this contract, you know, you can assume that people can gain this contract right here. So I'm going to change public back to private, and I'll leave it there for this video. And the next video, what I'm going to do is I'll work on the pick winner function. So stay tuned.